My name's Josh Pitters,
And I'm Savannah Farkins.
and this is our presentation on endophytes. Okay, so first we need to decipher exactly what an endophyte is. By dictionary definition, an endophyte is an endosymbiont, often a bacterium or fungus that lives within a plant for at least part of its life without causing any apparent diseases. Typically, endophytes are ambiguous and have been found in all species of plants studied to date. However, most endophyte plant relationships are not really that well understood. Endophytes also are known to occur within lichens and algae. Many economically important grasses carry fungal endophytes. Some actually enhance the growth rates. Others can actually cause diseases in people. So according to scientists, there's actually over 1 million different endophytic fungi taxa in the world right now. Shows that they're extremely hyper-diverse. And with all this diversity, we come up with a lot of different medications and uses for endophytes in everyday life, including antifungal medications, agricultural advances such as crop manipulation, making them grow faster, grow bigger, antiviral medications, biofuel productions, and also anti-cancer medications is kind of the new and up-and-coming market for endophyte research. So one of the major new anti-cancer drugs that has been released is called Taxol. It was developed in the early 1990s, and it's actually the first billion-dollar anti-cancer drug. Originally, it was thought to only be found in the yew tree, and it was found in every species. But recently, they've also found it in bald cypress in South Carolina. The chemical Taxol is actually only produced by endophytic fungi. And the more they're looking into it, the more they're finding that a lot of different endophytic fungi actually do produce this drug. Currently, they actually have to harvest it from the yew trees as the largest producing, but they're actually looking into trying to have it ferment the way penicillin's created so that they can produce it in a lab and produce it on a larger scale to make prices of the drug go down and make it more available to people who are suffering from cancer, because right now it's an extremely expensive drug and there's just such limited quantities because of how it's produced. So they're trying to mass produce it like they do penicillin, which would be a great thing for the world considering all the different types of cancers that Taxol can treat. So during our endophyte project, we actually compared two separate endophytes. We compared DMW 1038 and DNW 1037. To efficiently compare these two different endophytes, we actually completed a Kirby-Bauer test and measured the zone of inhibition on three separate bacteria. We did E. coli, Staphylococcus aureus, Saccharomyces cerevisiae. So when we conducted the Kirby-Bauer, we would measure the zone of inhibition 24 to 48 hours after it was placed in the incubator, and then using the zone of inhibition, we conducted students' t-test to see if there were any significant differences present in the. So when we first started this project, prior to actually looking at our Kirby-Bauer test, we came up with the hypothesis that both the endophytes DMW 1038 and DMW 1037 would both be effective at stopping the growth of gram-negative bacteria. This would be the E. coli in this experiment. So we figured on our Kirby-Bauer we'd have larger zones of inhibition from both endophytes on the E. coli plates. Our alternative hypothesis to that would be that there would be no difference in growth due to having the endophytes on the plates. So this just basically means that for all three, the E. coli, the staph, and the yeast, our zones would be the same across the board with no change, including comparison to our control.
So our objectives were pretty easy. We have three of them. Our first objective was to isolate an endophyte and isolating our endophytes to see if there was any zone of inhibition at all. Our second objective was to extract secondary and tertiary metabolites. Our last one was to screen metabolites for activity. This was to see if we had, at all, for any possible reason, activity to have antimicrobial, anti-fungal activity within our plant and the endophytes that it had. So to begin our experiment, we wanted to start with a clean leaf. This way we didn't have any contaminants on our leaf that would cause issues later on in our extraction. To begin with, we cleaned our leaf with 0.5% bleach and 70% ethanol when we finally rinsed it in distilled water. Then we thus had a clean leaf to begin our extraction. First, we started by cutting our leaf into small pieces and placing them on potato dextrose plate for growth. We wanted to see that outside of our extraction there would be any growth to see in our potato dextrose plate. After a week of allowing for growth, we then came back to cut our fungal culture into small squares with a sterile scalpel. From here we put it into the shaker flask with 100 milliliters of liquid PDA broth. This broth was basically used as a media to help aid with growth that we then allowed our fungal to grow for 2 weeks before isolating. So after our growth for 2 weeks, we came back and we blended the fungal liquid culture into a slurry in a blender, and then we kept it in a 500 milliliter flask. Now during this time, we wanted to make sure that nothing was contaminated, so we would rinse out all of our equipment in between each group and each step. After we blended it in a blender, we added equal volume, which is 100 milliliters of ethyl acetate solvent. Ethyl acetate is a media that evaporates easily to allow for the endophyte to be isolated further. And this was put into a fume hood because of the fumes and wanting nobody to get harmed. We carefully shook the solution and put an opened the stopper after each shake to vent. That way it didn't explode everywhere. And then we vacuum filtered to get rid of anything that wasn't the endophyte we were trying to get. Once we were done vacuum filtering it, we put it into a separatory funnel. That way we could separate the phases, and it was just another process of isolating an endophyte. During this time, we saw two phases, which was organic and aqueous. Organic is the top layer and aqueous was the bottom, and we wanted to keep the organic layer, which was the top phase. This was done by allowing the lower phase just to come out into a beaker, and then we got rid of that. And then we thus placed it into a fume hood to allow for ethyl acetate to evaporate. And then once it evaporated, we performed a Kirby-Bauer test to check the effectiveness, and we looked at the zone of inhibitions that each one of our endophytes created with the different types that we were testing it against. So as we look at this graph, we see gray is our control. Orange is DMW 1037 and blue is DMW 1038, and throughout the rest of the graphs, orange will be considered 1037 and blue will be referred to as 1038. Our controls show that endophytes have significant zones of inhibition and significant effectiveness when it comes to bacteria, and especially E. coli. And our own endophytes showed the same results as well. And we can see from our p-values, which is 0.0452 for our 1037 and 7.72 e to the negative 48. This agrees with our null hypothesis that there is significant effectiveness when it comes to dealing with gram-negative bacteria. So from here we can see that there is substantial difference. Our control is in the gray, 1037 is in the orange, and 1038 is in the blue. We can still continue with a null hypothesis, though it is going to be modified into looking at Staphylococcus aureus instead of E. coli. There is substantial effectiveness when it comes to the endophytes against Staphylococcus aureus. Our control did not have any, like, there were completely 0 millimeters of inhibition when it came to killing off Staphylococcus aureus. But DM1038 and DM1037 both has substantial effectiveness on it. It was a average of about 25 for 1037 and about 24 for 1038. So from this we can conclude that our endophytes were very effective if it came to wanting to treat an infection that included Staphylococcus aureus. So from here we are looking at a graph, another graph with our control being gray. We have 1037 being blue and 1038 being orange. From this we can conclude that when it comes to Staphylococcus cerevisiae, we have substantial inhibition, and even our control had inhibition of an average of 30, over 25, almost 30. And from here, and even our own endophytes had about 25 and 24. So from this we can conclude that our endophytes were very good when it came to being effective against Staphylococcus cerevisiae.
Once we had completed the student's t-test on the 2 bacteria and the yeast, they did show that both endophytes had antibiotic attributes by producing zones of inhibition. However, when it comes to the E. coli sample, only the DMW1037 was effective. So this did go against our original hypothesis that both would be effective against the gram-negative bacteria. So our hypothesis was proven incorrect, but we did learn that 1037 was effective against the gram-negative bacteria. These zones of inhibition in the gram-negative are comparable to antibiotics developed from ecomycins, directly correlated to endophyte research. So this just shows that the things that we did in this experiment are practical in medical research in everyday life. And here we have our works cited. If you have any questions, just feel free to email us. Thanks for watching our presentation.